last thing that we didn't go over yet is derivatives involving absolute values. Now there was that little, this is the second part. I believe it was on one of these slides, way back up here. Not that one. Not that one. Here we go. Okay, and we're going to be looking at this second one over here. Okay, so when I take the derivative of this, it's going to be basically like it's the derivative of the natural log of an absolute value, because we know that you can't take the natural log of a negative number anyways. So that's why they put an absolute value, because that forces it to be positive. All right, and basically you get the same thing. You're going to get this u prime over u thing happening here. Okay, so that means that you're going to have to decide what you're going to let your u be. So in this one, what should I let u be this time? Mm-hmm. So the derivative of u is going to be good. So du is going to be negative sine of x dx. So if I wanted to take the integral of this thing, so the integral of the natural log of cosine of x dx, right, we know that that's going to sorry, we haven't done integrals yet. I meant derivative.
I thought we let u equal cosine x.
Mm-hmm.
It is. It is.
Mm-hmm.
So let's just run over cosine x for that first
Well,
part.
yeah, I'm getting ahead of myself here. We don't need all this stuff, but I did need this one. Right, so, and this is really, when we say du over dx, that's u prime. Right, so when I take the derivative of this thing with the absolute values in it, I'm allowed to go u prime over u. Well, u is cosine of x, and u prime, we decided, was negative sine of x.
Oh, wait, isn't that tangent?
Close, because of the negative,
It's negative tangent.
tangent.
I was getting it. But then it's got to be inside the absolute value, correct?
The absolute value part, that was part of the little formula there. So this, when you take the derivative of a natural log of something with absolute values, you use this one. Okay, so that'll take care of it. So you just have to decide what the u is going to be, figure out what your u prime is going to be, and then you just plug them in. U prime in the top, u in the bottom, and then simplify anything that you possibly can. All right, last one, finding relative extrema. Right, so that was basically, that's a fancy way to say what?
Maximum.
Finding maximum and minimum. So we're going to want to take the derivative of this and then do what with it?
Find the top for 0.
Yep, set it equal to 0 and figure out what it's going to have to be. So if I go y prime here, all right, and we take the derivative of the natural log. Do you remember how to do that?
1 over that.
Give me the formula.
Isn't this 1 over that?
Okay, so when I take the derivative of a natural log, it's going to be 1 over whatever that was.
Okay.
Okay?
So how can it be 0?
Well, you kind of have a problem with that one. So remember, you can always rely on the other method anyways. Because we've got a lot going on in here, we can let that equal u, or let u equal dx squared plus 2x plus 3. That means that my derivative of u, or my u prime, is going to be 2x plus 2. All right, so when I do that, that gives me something up there to deal with. All right, can I factor anything in the top?
2.
Where will I have a maximum or minimum?
Bottom
Negative
factor.
1.
going to be at -1. The bottom won't factor, no. It looks like it might, because a 3 and a 1 will get you 2.
Yeah.
But one would have to be positive, one would be negative, but the signs force them both to be positive, so it's not going to. Okay, so x would have to be -1 in order for that to happen. So if I plug -1 back into the original and get 1 plus 2, so I'm going to get 3 plus 3, so the natural log of 6. So my point is going to be 1, and then whatever the natural log of 6 gives me some kind of decimal to plug in there, right? And then how would I know if that's going to be a maximum or a minimum? Remember?
What the thing's doing on both sides of
Mm-hmm. So if I plug a -2 into the derivative, so I'm going to get a -2 plus 1, that's still negative, times a positive, this is going to give me a negative in the top. I plug -2 down here, that's going to be a positive plus, well, let's see, I'm going to get a +2, that's 4, minus 4 plus 3, so I get a positive number, so negative over positive, that's negative, so it was going down, and then if I plug 0 in here, I'm going to get a positive in the top and a positive in the bottom, positive. So what is it?
It's minimum.
Minimum. Right, so really the rules haven't changed. I mean, you're still doing all the same things that we did when we were finding derivatives. It's just now you have a new trick. Now you can find derivatives, and then the next section we'll be able to find
without regular logarithms.
we'll be able to find integrals of logarithms. We use natural log most of the time. Remember, you can always change a regular log to natural log by doing that change of base formula thing. So we really only ever just deal with the one, because if you really want to deal with the other one, you can always change the base later. Easy enough?
Yep.
Okay. Here is your homework.